picture of it so now we can. Right. So go ahead and set them up like this, but these are the correct ones. And so let's get our cell over here.
Walk off with it, right? Yeah.
Yeah. Doesn't matter which one. I also want you to know you could apply current and monitor voltage. The reason why I did this was sort of more of a practical thing, that I don't want a bunch of current applied without monitoring it closely. So we're going to put voltage, negative voltage and negative current leads on one side, which is the green and the black. The black is our negative current, the green is our negative voltage. And for this measurement, we're going to put the voltage on the outside because we're applying it on the outside. Okay? We're going to measure current. It may not make a small difference, but I'm going to do that anyway. On the other side, we're going to put the white positive voltage lead and the red positive current lead on there. And it doesn't matter which one is which because it's completely symmetrical. Just make sure you've got good connections with the alligator clips. Okay, we're 21. Okay. Now we've got our cell. Got some extra 9s in our thing. So let's go. Ready? Okay. Now it should be okay. Now it's turning yellow, meaning I'm thinking about it, I'm resting, I'm not doing anything, but I'm active. And then we're gonna, you should see in just a minute, because we told it to rest. Heard it click. It's doing something, and you see this red light. So the red light is on. It's making a measurement. Now we can actually read in real time what the voltage is. We told it to apply plus 101 volt. You can see right there, it's reading plus 1 millivolt. And there's our current, 0.3 microamps. We're reading some current. It's fluctuating, right? We're going to get a readout of this. You can see it's going down. Okay. And we've got our current. And fortunately, we picked the right range in terms of low range because it's pretty low current. Okay. So we're going to see it seems to be fluctuating around. We have a lot of. Remember, the cell wasn't that good. We had a couple of issues with that. So. But now it should be, it's on step 2. You see this 2 number, that tells us it's step 2. Step 1 was rest, step 2 is potential static, so we stay there for 3 minutes. So we have another, we're 57 seconds into this measurement, so we got another 2 minutes to go, and so we're fluctuating around there. So I'm gonna move this thing a little bit too. I think this is the monitor control window. We have the batch file and schedule files, and those are the 3 critical ones. I can close this. I'm going to leave this monitor control because I don't want to turn this off. And there's another program here called Data Watcher, and this allows us to actually look at the data in real time in this program. It'll save it, but then we have to, so Data Watcher, I'm going to try to go to this, and I could see the data, but I just want to plot it in a way that's a little bit easier. So I'm going to remember how to do this. I think it's going to be import results data, and so I'm going to be data. I should be seeing the data that I just am collecting, and I don't know if I'm in the right folder or not because I don't know where.
You move the date modified and look at the most current.
There it is, right there. Okay, so let's see. I'm going to open that, and then I have to set the X and Y axis on here. X-axis should be test time. Y-axis is going to be my voltage, okay? Okay, I'm seeing I'm applying voltage, and then a Y2 axis I'm going to put as current, okay? Now you can see how noisy this is, and why do you think it's so noisy?
Just a lot of current fluctuation. It's moving too much because it's inconsistent.
Possibly.
Bad connection.
All those are possibilities. I want to think that we're pretty close to maybe I don't know if we're highly accurate. So there's a couple possibilities. We're pretty low current here. So I don't know if this is too low current for us to measure very accurately using this measurement for this particular material. Okay, so I don't, it's possible, I would probably redo this with a better cell. But we now stepped on to step 3, which is rest. I think we told it to rest for a minute, and then let's go and do another negative current, just to see what that's going to look like. Now you can see that, you know, this is a very ugly measurement. I think there's a way to do this real time, but I don't know if it's import data. Let me try this again, because I think there's a setting, and it's been a while since I did it, so I can't remember. Oh, here we are. Well, that's the voltage, and then the current. Again, you can see that. Let's see, is it doing it in real time? I think it stopped it. There's some setting in there. Anyway, so we stopped our current. I don't know. It's worth checking what the current resolution of the instrument is, because it may be noise level of this instrument. We may have to go to the other one to do better, or the titanium itself may be too low. The other thing you can do is bump up the voltage a little bit, right? You could certainly bump the voltage up.
But you have to be careful not to move out of that linearity range.
Yeah, so I don't know where we are on that. Above, I don't know. You'd like this as a good range, but it could be that we can still read a current here, but it's pretty low, right? But we would be looking out, you know, obviously there's a lot of noise here, right? But just for the heck of it, you can try, and you can, you know, pick, but I wouldn't use this as reliable data. This is too noisy. You can't quite see, we don't see a big thing down here, but this data is too noisy, and it probably first thing is remake the cell, then retest it again. But you know, the method works right now. The challenge is, it looks like to me we're likely approaching the current resolution of this particular instrument. I don't know yet, but I'm concerned about that. So that means you can bump it up a little bit. I wouldn't go more than ½ volt, just as a thing, just to see. If you want to run this one again with a ½ volt just to see what happens, you can. And then we're gonna, but then what we do is we make sure we're in a linear region, and once we have kind of reliable data, and we just pick whatever current we have that was steady state, right? If it was steady state current, we expect maybe a little bit here if there's some kind of ions. Although this Degussa, I don't expect to have much sort of ion conductivity, other than relative humidity adds a little bit of a proton conductivity probably from the water at the surface. So, but you know, we should have a nice peak here, and then we would take sort of the steady state region of our current, and then use Ohm's law to be able to determine what the resistance was, right? So let's see. Let's go back to our. Back to our data. We're now on the 4th step here, so it's applying. It's doing exactly what we told it to do, which is negative 100 millivolts. It's going as close as it can, right? And you can see this is getting down to 0.02 microamps, and so we're below not only just 1 microamp, 0.1 microamps. So that number makes me think we're real slow. This thing's not that great. Now the other thing I want to look at is I want to see if positive and negative, they would be about the same number, right? They should be, but it shouldn't really matter. We shouldn't really have to do it both directions, but we decided to do it for the heck of it, right? Let's go back to this data. There's a setting to be able to do the live data. Yeah, but I can't remember what it is. And then, so, oops. Voltage. We have, there we go. Uh-oh, I'm gonna reload this. Oh, it's definitely acting funky here, so I don't trust this. See how it's okay. You see how this one didn't show me? This should be 0 current here, but then on the negative side, it only went to this range, right? See that?
Mm-hmm.
And these should be kind of symmetrical.
It should be down here, right?
Well, no, it should be right here. So you're looking at two regions.
Here.
If we take this off, we can just plot the current here. Yeah, let's, just so it doesn't. We'll just look at the current instead of the voltage. See, here's 0. It went up, stopped, went back to 0, but then we put it positive and it spiked out here and then it didn't go here. So this is either, you know, some issue. It may be, and I'd probably try to redo it one more time and bump up the voltage a little bit. Otherwise, we're going to have to go to the other instrument to do it.
Okay. And then we want to clean all the parts of the isopropyl.
Yeah, clean it all out. Take it apart, clean it out, and make sure to not
Drying
lose
oven or
anything.
no?
Don't put it in the drying oven. Just let it air dry.
Okay.
It won't hurt it, but I'd rather leave this set up and away from other stuff. There's too many parts to lose, so keep it down there.
Okay.
You can then, there's a special program that you got to use to import this, or you can do it in Excel, but you have to have a macro on it. So this particular version of Excel on here has the macro. We need to put the macro on the other one. So you got to go to Excel, okay, and then you have to, I think it's in add-ins, and you have import data, right? I want to do I think we go to import data, and then we're going to pick that sample, okay? So we're going to pick this sample where we were at, and then we'd have to find where it saved it. I'm going to pull that up again, but let's say I knew where that was.
Okay.
Oh, there it is. I know where it is. Now I'm going to import it. I don't really want to plot it. I'm just going to import the data.
Okay.
So it takes the results file and turns it into Excel data. Now I have it in version Excel. I can see what the applied voltage is. You can see this was negligible current, negligible voltage. Here's my actual voltage I applied, and here's my current. So now I could plot this number and see that. Okay? And save this version. So that's how to get the data once you do that. Let's see if this is done. We can go to our monitor and control window here. Let's see. It's not quite. Oh, it says it's finished. It's finished. See? And it's no longer red. So we're done. Take it off. If you want to, I want to repeat this maybe with Sabovine here or something.
Yeah, that's what I was thinking.
She might have made some improvements. You know, obviously that it's too noisy and that didn't work. We make the cell, we put it in there, try to bump the voltage. If that doesn't work, we got to go.